Hi, in this short tutorial I will teach you how to make interactive or animated scientific visualizations with Makie.jl. In short, I will show you how you can do videos like this one or interactive applications like this one. So let's get started. I have a script here that I will follow and I will also upload on GitHub, so you can download it and go through it a second time, don't worry. Here are the steps that we will follow. Let's start immediately with the most important thing, which is observables. First, I load some packages I will use, but obviously you don't have to use the same packages as me. Now, what are observables? Observables are a mutable container of some object of some type, and this can be of any type. And the value of an observable can be updated on the spot, just like any other mutable Julia type. If you're familiar with the ref structure, observables and ref are very similar. Now, the important part here is that observables can be listened to. What does this mean? Well, what I am doing here is I'm creating an observable that has values of type int, integers. And what I do here is I add a listener to this observable. A listener is some kind of function, or generally a pipeline, that will get called whenever this observable is updated. So what this listener will do is will simply print this string using the value of the observable. So let me show you how this looks like at the REPL. Some error messages here. So O is this observable and L1 is this listener. What I'm doing now with this syntax is I'm updating the value of the observable. That's the syntax you do it. So you call the observable with brackets, but without any actual indices. So you see there is no 1, 2 here. There are no indices. It's just open, close brackets immediately, and then you give it some whatever value. It doesn't matter. And as you can see, the listener is called. The listener is called, and its print observable now has the value whatever. So that's how observables work in a nutshell. Why do we care about observables? Well, because Makie is hooked up into this observable listener framework, which means if any plotted element is already an observable, Makie understands this, and if you change the observable, the plot will change as well. Let me show you a very simple example. So here I will plot, let's say, 4 random numbers whose y coordinates is initialized as an observable. And I will also attribute some value to the line width that is also initialized as an observable. Now here I create a plot of these random numbers, and keep in mind I'm directly giving to the plotting function an observable, right? So this is an observable. Okay. Let me pull the plot. Sorry about that. You probably have to look at this as well. So what I'm doing now is I'm going to change the value of the line width. And you see, the moment I update the observable, the plot reflects this change. Also, I could, for example, change the value of the random numbers as many times as I want, and the plot immediately changes. Now, this simple process of creating these observables and giving them to Makie is the basis both for animations but also for interactive applications. All right? So that was step 0. So what is the step 1 for making your own animations and applications? Well, my suggestion is to initialize your simulation or the data structures or whatever you have in a stepping manner. This means try to create a step function that contains or that takes all your data and moves them forwards one frame or one step. So here I have some code that we don't really have to go into detail that will simulate the double pendulum and transform the coordinates of the double pendulum into a plottable format. We really don't have to care about this. The point is I have this nice integrator over here, and here I create a function that will simply progress my simulation for one step. So here this will step the integrator and it will translate the coordinates into a plottable format. Obviously, for your simulation setup, something else will happen. We don't care. What we care is that we have a function that takes your data and progresses them one step forwards or one frame forwards. This, of course, could work with pre-existing data. So you create a data set of, let's say, 1,000 steps, and then you simply step through it by just changing the index of this data set. But I prefer to do it this way because I can do infinite simulations, and this is nice for interactive applications where you don't have to worry of running out of data. Perfect. Now step 2 is to initialize the observables of your animation. And what is this? This means that you have to first decide which parts of your plot will be static and which parts of your plot will be animated. I have already made the plot, so I have made this decision for us. And I know that the coordinates of the double pendulum have to be animated. So here what I'm doing is simply creating two observables. One observable is the rod. This is the lines that connect the double pendulum. And the other observable is the balls, which is the discs that are at the ends of the rods. And the only reason I have two observables here is simply because I will plot these two things with different ways. One will be a lines plot and one will be a scatter plot. So far, so good, I hope. The next thing that I want to be animated in my plot is the tail of the pendulum. So as the pendulum goes around, it leaves a trajectory that fades out continuously. And this also has to be an observable because it will obviously be animated. And the way I will do this is by using a circular buffer. And I will do this because it will make the code later much simpler. A circular buffer is a data structure that contains a specific amount of data points, let's say 30. And if you push something to this data structure, the last element gets taken away. And we will use this fact to just have a tail that has a specific length, and we don't have to worry about taking and removing elements all the time. So that's the second or the third observable of my simulation, and I have created it. I'm going through this part a bit fast because this really depends on your specific simulation, and your specific simulation will probably not be again the double pendulum. So we don't care about the specifics, only about the general steps. Perfect. Now step 3 is once we have initialized the observables, we plot them into a figure, and then we plot any other static elements. So here I am initializing a figure. Let me pull it up here so that you can see it and pin it. Okay, a bit on the side. Nice. I am creating an axis inside this figure, and now I'm plotting the rod of the double pendulum, and then I'm plotting the balls that are at the end of the rod. So you see one ball is here and the other ball is here. Okay. The other thing I'm doing over here is plotting the tail. And you see here I'm doing something nice. I'm creating a vector of colors for the tail so that the fourth attribute of the color, which is its alpha value, decreases as we go towards the end of the tail. This is what will create this nice fade out of the tail of the pendulum. Anyways, I'm making these colors, and here once again I'm doing a lines plot. The lines plot has as argument an observable. This observable has a vector of two-dimensional points, which are the coordinates of the tail. And if I change this observable, the tail of the pendulum will change, just like I showed in the start. I've plotted this as well. Now, obviously, you don't see anything here because every single point of the tail is the same because I haven't actually run the simulation. But you will see once I run that things will change. Now, after I've plotted the observables, I now can plot the static elements of my plot. Of course, you could plot the static elements first and then the observables. It doesn't make a difference. And we are ready to go. What does this mean? This means that we have to create the animation stepping function. This means that we make a simple function, like the one you see here, that progresses the progresses the plot for one frame. This function, of course, must first progress our data one step and then update the observables to the new data. And this is exactly what I'm doing here. First, I'm progressing the actual integrator for one step and I'm getting the new data. These are the data for the next step. Then I update my observables. Remember, this is the rod of the double pendulum. Can you see the end? Yes, you can see the end. This is the rod of the double pendulum, which I am updating on the spot. And these are the balls that I'm updating into new coordinates. Finally, I'm pushing the new position of the pendulum into the trajectory observable. And remember, this is a circular buffer, so this removes the last element, so that in total I have only, how many? Only 300 elements in this example. Now, something important, here I did not do the assignment syntax. As you can see, this is the assignment syntax for observables, which I'm not doing here because I'm using the push function. This does not trigger an update on the plot. That's why I have this final line over here, which is a bit silly. I'm assigning the observable to itself, but it doesn't matter. I still have to do this to call the assignment syntax for observables. All right? Now this is the animation stepping function. The fifth step is to test it. This is something I always do to be sure I didn't do any nonsense. So how do you test it? Well, you write an extremely simple loop that calls the animation stepping function and then the slip function so that the update is reflected at the Makie plot. So let's run this, and thankfully it works. Obviously I have predetermined that it works, but let's pretend to be surprised. And that's the basis of making animations. Now, there are two things to cover. First, how to actually save this into a video. Second, how to make this interactive. Here I just made a function that takes an initial condition and initializes the figure. What I did, I simply took everything I have written so far and grouped it into a single function purely for convenience purposes. Okay? So what this function does, it is simply initializes the animation. Now, how do you make this into a video? How do you record? You use the record function. The record function has the following syntax. It takes a figure instance as the first argument, where to save the video as the second argument, and a frames iterable. So here I am saying, okay, let's create a frame 1 to 200, so 200 frames. And also other keyword arguments like frame rate. And you call it in this format, record whatever, and then do I. I will be simply the frame number or the frame identifier, you could say. What do I do here? Here is all your code that animates the plot or that changes plot elements. And what I want to do is I want to step my animation 5 times for each recorded frame, which is exactly what's happening here. Now, at the end of this code block, doesn't matter what happens, the Makie library will record a frame and then continue the loop. And if you run this, you get exactly the video I showed in the beginning, which is this one. So that's how you make videos. It was quite easy. The most interesting part is how you would make an interactive application. And I will show you 2 things you can do for interactivity. Of course, Makie has a large library of widgets and buttons and sliders you can use to make more detailed interactive applications, but let's see the basics first. So once again, I initialize a clean figure. It doesn't have anything besides the plotted pendulum, and also I have access to the observables and the integrator. This is extremely important because we will be modifying them. Now, the other thing I will do in this figure is add a button, and I will add it below the axis. So let's run this command, and as you can see, it added here this button. At the moment, it doesn't do anything. I can press it, but it doesn't do anything. Now I will create this very nice magic code block that will do the following. Whenever I press the button, the animation will start updating itself. And when I press it again, it will stop. So it will be like a pause play button. And to do this, I have created here this code where it first initializes one observable that is simply true or false. So this is simply so that I know whether the animation is currently playing, it's running or not. Yeah, that's why I have the is running observable. And here I create a code block of what will happen when I click on the run button. And you see I have two such code blocks. Now the first code block, what it does, it is simply taking the is running observable and changing its value to its opposite. So if this was false, it's not running. If I click the run button, it will make it true. It is running. The second code block is doing the following. It says while is running is true, and while the figure is open, because we don't want the simulation to run if we close the figure, well, it simply does the animation step and then it calls the sleep function. It could also call the yield function instead of sleep. Doesn't really matter. So that's the code related to the run button. Now I have this code, I just run it, and now you see if I press the run button, the simulation starts, and if I press it again, it stops, it runs, it stops. Honestly, it's really unbelievable how easy this is to do. I'm really impressed with Makie. I say this pretty much every day of my life. The other thing I will do now is I will add an interaction on top of the actual plotted axis. And what I will do is when I click the axis, I can process the coordinates I clicked into and make the pendulum go to these coordinates and start from 0. Now to do this, we have to do two steps. The first is to obtain the axis we have and remove an existing interaction. Because by default in Makie, if you click on the axis, it actually zooms into the axis. We don't want this, so we remove this. The second thing we do is we add a trigger using the select point function. This is a function provided by Makie. And what this function does is that once I click on the axis, you see now, I highlighted a blue point. And what happens is this S point is an observable. So let me show you what this means. S point, this is an observable that has simply the coordinates of where I clicked. And you see, whenever I click here somewhere, the observable will update. So if I type it again, it will be in a different coordinate, you see? So now this is existing and it's triggered every time I click on the screen. So what I have to do now is quite simple. I make another listener to this S point observable, and whenever this listener is triggered, I just reconfigure my pendulum to a different starting position. Now I've run this code, and when I click on the axis, let's say I click here, you see that the pendulum goes into this direction. If I click here, it goes into this direction. Now what's really cool is that this works also live, like while the pendulum is running. So now if I click here, you see it always goes there. Pretty cool. That's it. That's the end of the video. I hope it has been illustrative into how I go about making these animations. And it's really amazing how simple it is to make these things. So thanks for watching and good luck making your own interactive applications with Makie.